Harvard School of Public Health survey of undergraduate students, 2,105 of the 10,904 respondents were classified as non-drinkers. So, if we define the population and parameter of interest, the population, it'd be good if you would take a pause and see if you can get this by yourself. All undergrad students in the United States. And the parameter that we are looking at is the proportion of the undergrads who are non-drinkers. So we need to confirm the conditions for constructing a confidence interval for the true population proportion. Confirm that the conditions are satisfied. So remember, you need to do this before you actually calculate your confidence interval. So once again, we're looking at RIN. Do we have the random condition satisfied? Well, in this case, we will make an assumption. We will assume that Harvard, being a very, Harvard did do a random selection. That's a fair assumption, but we do need to state it. So RIN independent. So this was likely done without replacement. So therefore, the 10% rule condition applies. And so it is likely that there are more than 10 times 10 times 10,904, or in other words, 9,040 undergrads in the United States. Our final condition we need to check is the normal condition. So we're going to use the sample proportion as an estimate. So n times p hat equals, first we could calculate p hat. So that would be 2,105 divided by 10,904, which is approximately 0.19. So we can calculate 10,904 as n. Now you could put in the 0.19, but I'd like you to just have a look at what happens here. 2,105 over 10,904 is simply 2,105, which of course is greater than 10. That's the number of non-drinkers in our sample. We also need to check n times 1 minus p hat. Once again, you're going to go 1,904 times 1 minus 0.19, or 2,105 over 10904, which, if you work it out, is the total number minus the number of non-drinkers. 2,105, and that of course is also greater than 10. So that would be the drinkers. All right. We now need to calculate a 99% confidence interval for P. So for this, let's just do our sketch. We are looking at, for 99, we want the shaded area here. And so we need to look at the tail areas. 1 minus 0.99 is 0.01. So divide that by 2 equals 0.005, which is the area in that section. So from table A, or you can calculate it in this manner. So the critical value is equal to inverse norm of 0.00501, and you get a value of negative 2.58. So therefore, the 99% confidence interval equals 0.19 plus or minus 2.58 times the square root of 0.19 times 1 minus 0.19 divided by 10904. So this is our standard error of our statistic. This is our, the 2.58 is our critical value. And the 0.19 is our point estimate. So interpret the interval in the context of the problem. I am 99% confident that the population proportion of non-drinking undergraduates is between, and you can do the calculations for this, 0.1802 and 0.1998. All right, so let's look at another example here. Number 2, a company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants to have some idea of the sample size. Wants to have some idea of the sample size that she will be required to pay for. One critical question is the degree of satisfaction with the company's customer service measured on a 5-point scale. The president wants to estimate the proportion P of customers who are satisfied, that is, to choose either satisfied or very satisfied, the two highest levels on the 5-point scale. She decides that she wants the estimate to be within 3% at a 95% confidence level. How large a sample is needed? Okay, so let's just highlight some of the key points here. She wants to have some idea of the sample size. And we want to estimate the proportion of customers who are satisfied. And finally, we need to be within 3% at a 95% confidence level. Okay. So, our calculation for confidence interval is our point estimate plus or minus the margin of error in other words, the point estimate plus or minus the critical value times our standard error. Now, we want the margin of error has to be within 0.03, within 3%. So for our 95% confidence, our critical value is 1.96, as we found earlier. So therefore, we will have to, in order to calculate what n is, we need to do some rearranging first of all. So a little bit of algebra. We'll take our margin of error. We know it has to be less than or equal to 0.03. So I'm going to multiply both sides by the square root of n, which leaves the critical value times the square root of p, times 1 minus p hat is less than or equal to 0.03 square root of n, and then divide by 0.03 and square everything. All over 0.03 squared is less than or equal to n. And if I tidy this up, I'd have my z-score, so my critical value over 0.03, which was my percentage that I need to be within, squared, times the proportion, sample proportion, and 1 minus the sample proportion. So now I can plug my numbers in. I get 1.96 over 0.03 squared. Now, what are we going to use for our sample proportion? So here's our key thing. To maximize n, in other words, well, maybe not to maximize. We need to maximize p times 1 minus p in order to make sure we don't underestimate. So in order to maximize that, we're going to let the sample proportion equal 50%. Okay, it has to be that has to be a maximum. So that's a key thing here. We have to maximize that, so we're going to let the sample proportion be equal to 50%. So in this case then, we have 0.5 times 1 minus 0.5. And all of that is going to be less than or equal to n, which therefore gives us 1067.111 is less than or equal to n. Hence, we need to round up, so n must be at least 1068.